All right, welcome everyone. Today's panel discussion the topic will be sustainable water management in the Permian Basin. It's an honor and a pleasure to be your moderator today. My name is Miguel Pena. I am CEO of TenEx Technologies. We provide a slew of completion and production specialty chemicals for specialized to solve problems in the oil and gas industry. The focus for today's panel will be sustainable strategies and innovations in water sourcing, recycling, and disposal, specifically in the Permian Basin. We have a few objectives that we're going to try to cover. I'll do my best to moderate and get through all of them. First one would be address key challenges in water sourcing, reuse, and disposal. Discuss ESG-driven water management solutions and explore innovative technologies for sustainable operations. With that, I'd like to introduce our panelists. We have one panelist who's running a little bit late. He'll be joining us shortly. But in the meantime, we have Jeffrey Cook. Jeffrey, if you give yourself a brief introduction, that would be great for the attendees.
Appreciate it, Miguel. Yeah, happy to be joining you guys today. My name is Jeffrey Cook. I'm the Vice President of Facilities Engineering at Aris Water Midstream. Been in the industry for about 18 years. First 15 years was all upstream production operations, and then joined the Aris team 3 years ago. And just the primary responsibility that I do is manage and execute the capital projects team throughout the year, building and installing new facilities from pipelines, reuse facilities, ponds, and SWDs. So happy to be joining you all today.
Thanks, Jeffrey. So we'll kick it off with the first topic, which is water sourcing and supply constraints. So just based on your experience at Aris, what are some of the biggest challenges today in securing sustainable water sources in the Permian Basin?
Big challenge that we have, and it kind of dovetails into the last session that you guys were talking about, which was with respect to increased efficiency on the operator side. Because initially we built and designed a lot of our recycle facilities to recycle and treat water at a 100,000 barrel a day rate, and then transfer that out to the frac site. With efficiencies at the frac pad, we've had to meet much higher rates, stepping up to 150, 175, and in some cases 250,000 barrel a day rate. And so for that, it's become like a continuous evolution, where we're having to navigate the balance between rental equipment and investing more capital for permanent facilities. And that's just kind of a grind. You got to stay ahead of it to keep your operating costs down so you can run a sustainable business. And then the one thing that I would add on to that as well is the completions activity is ever moving. It moves all around the Delaware Basin, and there's a big challenge that we're all seeing on the utility side, and that is access to overhead power line power from whether it be XL or Encore. And when we don't have access to line power, that's when we have to rely on diesel rental pumps, and that's not our preferred choice.
Presumably, it's much more expensive.
Much more expensive. It's not as reliable. It's more challenging to program in safeguards from a layer of protection standpoint to mitigate spills and things of that nature.
Makes sense. Makes sense. How are operators reducing their dependency on fresh water, given some of these challenges? Are you
Well,
experiencing some of that?
yeah, what we've done is we have a large pipeline network from a produced water standpoint. We have over 750 miles of pipeline. And so our recycle facilities are integrated as a network on the inlet side. Now, initially, what we kind of treated all these recycle facilities as standalone kind of sources for treated produced water to feed the frac jobs. And now we're making arrangements on the tailgates of those facilities so that if we're feeding one frac job for a customer, we can potentially be supplying treated produced water from more than one of our permanent recycle facilities, so that we can achieve those higher rates while still taking full advantage of our permanent recycle facilities, as opposed to going out and standing up more temporary facilities that are going to have a higher operating cost, and as well, not all of the safeguards that we want to have in place from a spill risk mitigation standpoint.
Got it. That's great. So I imagine that network of recycle facilities and pipelines that Aris has gives y'all a pretty strong advantage in the marketplace.
Yeah, it does. And like our commercial guys are always trying to stay ahead of and find new opportunities. And it takes a long time to get permanent right of ways. And we have a meeting about every other week, I do, with respect to working with the utilities for putting in new load requests with XL and Encore and trying to stay ahead of development plans. And so it doesn't always get done. Sometimes we do have to rely on lay flat lines for treated produced water and third-party water transfer companies. But it's a good business. It can be really rewarding if you are staying ahead of it.
Sure. Sure. Well, that's actually a good segue into the next topic, which is produced water recycling and reuse. And based on your experience in the marketplace, in the industry, looking at your competitive set, and also at Aris in particular, what are some of the advancements that have improved produced water recycling, in addition to some of the things you already mentioned, like your integrated system with the recycling facilities on the inlet side, et cetera?
A key thing, and not to repeat the issue too much, but is we started viewing our recycle facilities as permanent facilities, like we've seen and built our SWDs. Our SWDs had improved remote monitoring. They had all the shutdowns and controls from start to finish of the facility with respect to high pressure, high level, and low level kills. We've added that at all of our recycle facilities. We invested the capital for electric motors and VFDs. And then as well, we installed PSVs on the inlet of the facilities to protect against water hammer. And so all of that was spill risk mitigation, but in turn, it gives you improved uptime. It allows you to treat more water, stay ahead of the frac, and continue to run a solid business. A lot of the facilities that we saw and operated in 21 and 22 had a lot of rental equipment, whether it was containments or lights or pumps. And that's just a kind of a never-ending cycle that you're always chasing your tail on. With respect to advancements and improvements, with my focus on kind of facilities engineering and facilities design side, one of the key things that I think is pretty neat is there's a lot of AI remote mobile cameras that you can install. And those cameras have the ability to detect anomalies for what they're looking at. And they can send alarms to your control rooms, alarms to your operators, whether it's a spill, whether you've got a motor that's running hotter than it should be. And so we're leveraging that type of technology as well. We still have manned operations 24/7 at those recycle facilities, but we're adding that AI remote monitoring capability to just take it to the next level.
That's awesome. That sounds like another panel. AI in water recycling. Thanks for that thorough response there, Jeffrey. How do you all assess water quality for reuse and completions? What methods do you use? Is there any specific technologies, or how do you do that?
We've got the connection points to treat the produced water coming in upstream of the AST, downstream of the AST. We mostly use DAF units where we knock out a lot of the iron, and as well we have the capability to inject chemical downstream of the DAFs, and then we have recycle lines to go back into the AST if we've got a water quality issue, and then from there we'll typically discharge into a million barrel pond, and then from there we've got a volume of capacity where that's where we're transferring out of to go to the frac site. And so that also allows us some response time if we have an issue within the recycle facility if we're dealing with some sort of emulsion or paraffin, or maybe there's some sort of increased level of iron sulfide that we're dealing with. So kind of the combination of all those things coming together have worked well for us. And then as well, we've got a kind of another division of the company called beneficial reuse, where those guys are running various pilot projects with other operators to produce water treatment at the next level. And we're always learning new tricks of the trade from them and trying to incorporate that chemical treatment technology into these existing facilities.
Awesome. Awesome. And then on the reuse side, how are pipeline and storage infrastructure evolving to support water reuse? Or said another way, support the increase in water reuse over the years?
What we're doing this year, and we did at the end of last year, was we've gone back to some of our existing reuse sites, and where we've had footprint to add more pumps and more DAF units, we've done that. So we could take those sites from 150 to maybe 175,000 barrel a day rate, or excuse me, 100 to 150. We're doing that. We're also looking to see where we have excess electrical capacity, and where we do have that, we're certainly going to try to add pumps and add DAF units so we can take those recycle facilities and increase their treatment rate. We're trying to permit and make shovel ready ponds at every recycle facility that we have within the network, and constantly looking to permit and get surface easement, whether it's state, BLM, or fee, throughout New Mexico, to align with producers, to align with their development plans from all the way for the next 2 years, 2025, 2026, 2027. And really the longer runway that we can get from our core customers, the better. So we can get out in front of right away C-147 permit applications for the state of New Mexico for the ponds, and especially on the utility side for power line access.
Great. I'm sensing a common theme here, and all goes back to the original point you made about just efficiency, improved efficiency at the end of the day. It seems to be, that's kind of the goal in everything that y'all do, which is great. What are some of the bottlenecks, logistical bottlenecks in large scale recycling operations that you've experienced?
See, bottlenecks, I think, would be if we're expanding an existing site and the footprint's not changing, and this is the same on the upstream side, it's usually not that hard for us. Whenever we have to rely on right-of-way application or something that requires a permit, it's really challenging to align that schedule with the commercial opportunity that you're trying to chase, especially with respect to a pond. It doesn't take that long to build a pond. It does take a long time to bring to the table an integrated plan with pipelines into the pond, out of the pond, and have all the surface easements from start to finish align with when the operator wants to start frac. And with oil price dipping below 70, frac schedules can change frequently, and they can move forwards and backwards. And we try to do everything we can to have as many shovel-ready projects so that when those changes happen, we can go out there and execute.
Great. I'd love to dive in a little bit deeper on technology and innovation with you, Jeffrey. Based on your experience and based on Aris's capabilities, what would you say are the latest and greatest cutting edge technologies that are transforming water treatment and disposal?
I would really have to defer the technical aspect of that to Chad and Lisa, who head up our beneficial reuse programs. But they're doing some really interesting things, and they've got partners with other operators that are involved running pilots for the last 2 years, and then trying to kick off some other ones. But some exciting things that I see that are out there are treating produced water to the levels that we could responsibly and legally grow crops like cotton, or potentially have desalination projects to look at reservoirs to discharge into. I mean, I think those are really cool projects, especially with traveling out to West Texas, New Mexico area as frequently as I do. I mean, if we could come up with a way to have renewable water sources and kind of rejuvenate the area, that could be a win-win for everybody.
That sounds really exciting for sure. What about on the automation and analytics and automation side, enhancing water system performance? I know you mentioned a little bit about AI. Anything you can share there that be worth it for our audience?
Trying to think. I mean, our whole system is tied into SCADA. We've got a control room that operates 24/7. Very, very similar to other midstream companies and upstream companies. The key things that we're doing would be the Andium cameras, the AI cameras with respect to detecting anomalies at locations. We're also evaluating other water quality meters at custody transfer points to try to detect when we have an increase in H2S potentially coming in. That's easier said than done on the water side of the business. It's pretty common to be done with natural gas pipelines, but not so much water. So that's something that we've trialed some probes, we've trialed some skids, and that's still a developing technology. Trying to think. We're also trying to develop some, in-house technologies where we can detect if we're going to have if we've had a pipeline upset, whether it be at a facility or along the route. But that's just kind of your normal pressure anomaly analyzation.
Sure. All right, great. Cost. Let's talk a little bit about cost and economic impacts. What do you see are the key cost drivers in sustainable water programs?
Certain pipelines, when you get around municipal areas, Carlsbad, the cost of right of way, the cost of throughput can be something that you have to navigate. But certainly still it goes back to power, and we're not making the development plans. We're working with the operators to try to stay ahead of their development plans, but I still go back to power. It takes a long time for us to get utility power to locations, and one of the things that we've done with our operators is where we have a good relationship, we've set up deduct meters, whether it be direct with the utility or with the operator. But sometimes they're also constrained for power, especially if they're running a lot of ESPs or something like that consume a lot of horsepower. But really, that's something that I think that we all struggle with is the rentals, the diesel fuel cost, and that can very quickly increase your operating costs and get out of control.
Understood. And then how would you say Aris justifies? I mean, you guys have a pretty sophisticated network of water recycling facilities, pipelines, and DAF units. How do you justify long-term investment in your water infrastructure or any new projects that you have in the pipeline? Presumably power is probably a big one.
Yeah, we're continuously looking at the utilization of those assets and, looking at development plans, whether it be public or private, or what's in the public databases for where new wells are being drilled and completed. And then it's proved to be a good business for us, especially in the last 2 years. So as we can see operators are investing in the area, we're going to continue to invest in our water assets. and always look to build more pipelines, more ponds, and recycle facilities, because that's a really big part of our business. And then, you know, we're where there's opportunity, we're looking to develop other parts of the basin as well, potentially out of basin disposal to just take it to the next level.
Awesome. All right, let's jump to environmental impact and risk mitigation. What practices, based on your experience at Aris, do you see as being most effective for minimizing environmental risks in general from water disposal?
With that, I mean, there's a few things that we're doing. First, we have a seismicity report that we monitor every week, looking at USGS public data and overlaying that with our system and understanding where the hot spots are with relation to existing SWDs. We always operate underneath the permit pressure limits, and everything's tied into SCADA from the tubing, casing, and downstream of the H pumps. And we've got high pressure alarms and high kills to make sure we always stay within the operating guidelines. And then as well, like I was talking about with our commercial team, I mean, we're going to do everything we can to recycle and redeploy that treated produced water, as opposed to having to handle the water and inject it downhole. So that's a big part of our business. And because we've got a good network, it allows us to be flexible and do so. As well, to mitigate seismicity risk, I would say is we did purchase surface acreage outside of the basin for long haul disposal. And that's something that we're looking to develop as well, to take the water out of the basin and just remove that risk.
And then the goal would be to treat it on this new acreage.
At the new acreage, there would be disposal. There would be some treatment. We would look to leverage what I was mentioning a minute ago with respect to the beneficial reuse team, where they're evaluating deploying it at non-edible crops, or whether it be data centers or other kind of alternative energy components.
Right. All right. Next topic we'll jump to is industry collaboration and future outlook. On the Aris side, what partnerships do you see emerging to improve regional water sustainability, and how do you see the future of water management evolving over the next 5 to 10 years? That's kind of a double question, but I think they're both tied together.
I would see the partnerships, we're seeing them in real time right now with the pilot programs that we have for beneficial reuse. We're also looking to do some partnerships with operators to deploy an iodine extraction plant on kind of the tailgate side of our treated produced water facilities, where we would be harvesting iodine and, you know, turning that into a commercial opportunity to sell to the downstream market or medical market as well. So it's kind of a two-part question, is like other companies already have iodine extraction technology that we're going to partner with, and then the operators are already involving in creating the technology for beneficial reuse projects and desalination projects. So we need to take those pilot projects and make them commercial so we can scale them.
Awesome. All right. Looks like we may have, thank you for that, Jeffrey. Great job on answering all these questions. What a great business. And, you know, it's exciting to hear some of the things you guys are working on, and exciting to see what some of these, you know, pilot projects you just mentioned, how they end up coming to fruition. We have some questions from the audience that we'd like to share with you. You can give me a second here, I'll pull them up. Okay, so the first question is, how can the integration of hyperspectral AI-driven camera systems with high-resolution, multi-parameter water quality meters enhance the early detection and classification of spatiotemporal anomalies and produce water management within the Permian Basin? Specifically, how can machine learning models process spectral signatures, turbidity shifts, TDS variability, and hydrocarbon fluorescence patterns to optimize anomaly classification, minimize false positives, and improve predictive maintenance in disposal and recycling infrastructure? I think I might need a PhD just to understand that question.
Yeah, I mean, that's a good question. I mean, how we're using it right now is our recycle facilities, they're 24/7 operations. They're manned facilities. We typically have 2 guys on days, 2 guys on nights, and they're tough conditions, you know, they're remote conditions. And so by adding in these cameras to monitor the site, we can detect if there's a spill on the permanent containment. We can see if a charge pump has a seal that is blown and it's leaking some water there. As well, if you have an emulsion, we can see through the AST, we can see through certain tanks and detect emulsions within those tanks. And if you see a change in the pad thickness, all of these things would give you indications that we need to look into our chemical program, or we need to call our pump maintenance team, and we need to take a planned shutdown and replace a seal. And if we have a spill, we need to find where that spill is coming from. Is it at a polyflange connection that has gotten heat and that has gotten hot and expanded, or has one of our high level transmitters in a tank or the AST not tripped an alarm or not tripped a shutdown, and we need to look into that. I mean, that's how we're using it right now, and we'll continue to look at other opportunities.
Awesome. What technological innovations are helping to improve water conservation in the Permian Basin's energy sector?
I mean, that is our pilot program, and I would honestly just defer you guys to our public website, and you can see literature with respect to beneficial reuse. You can see who's involved in the pilot programs and the different type of technologies that have been integrated. And we've got plans in place to bring those projects and make them commercial opportunities. And then that would enable us to not be injecting produced water down hole, but to start taking advantage of that produced water and deploying it for agricultural use or harvesting minerals from the water.
Great. Next question is from the attendees. How does your team handle microplastic treatment at in the Permian Basin?
Pass.
All right.
I don't know. I don't know. Sorry.
We'll take a pass on that one. No problem. The next question, I think you've already answered, but maybe you can expand on it a little bit. What role does real-time seismic monitoring play in managing induced seismicity risks from produced water disposal?
We don't have any real-time monitoring. I have worked at a company before that has had that. Like we're monitoring events every week. We have a once a week report, and if there is an event, we'll have a report come out as well. And we look at the radius proximity to where the event was, and how close it is to one of our active SWDs. And then the NMOCD has put out guidance for seismicity response, and it's voluntary response for operators like us. If we're within an event that's 2.5, 3.5 magnitude, and we're adhering to those guidelines and recommendations strictly. So where there is an event, potentially we will have to curtail that SWD for a period of time and work with the NMOCD to understand what we need to do.
All right. Next question. I think there's one more, Ahmed. what role does desalination play in addressing water shortages in the Permian Basin?
It's another outlet, and there's areas to dispose of it that could really increase outlet capacities quickly. We need to bring the technology from the pilot phase to the commercial phase. We need to get through a few regulatory hurdles, and we need to continue to work with the state of New Mexico to show them the benefits and show them that we can do it responsibly. And then we could discharge into rivers or streams, which is done elsewhere in the lower 48. It's just not done here in the Delaware Basin.
Got it. Great. Thanks, Jeffrey. Appreciate those responses. Looks like we have Dr. Marshall Watson has joined us. Hello, how are you? My name is Miguel Pena. I'm honored to be your moderator today. Thanks for joining. We were expecting you a little bit late, so no issue. And you're just in time, as Jeffrey just got through large majority of the questions, except for one, which I saved for you. But before I ask that question, it'd probably be helpful for you to just give a little brief introduction of yourself for the benefit of the attendees.
Okay, my name is Marshal Watson. I am the Department Chair of Petroleum Engineering here at Texas Tech University. I'm also a member of the Texas, or one of the directors of the Texas Produced Water Consortium, housed here at Texas Tech. That's was funded by Senate Bill 601, and we are progressing towards setting up several pilots where we'll provide testing and some guidelines as to analyzing the water that's been processed, produced water that's been processed for beneficial use.
Fantastic. Well, welcome. The one remaining, there's a couple of remaining questions around ESG, regulatory and ESG considerations, and would love to get your take on them, Marshall. How do regulatory frameworks impact water management strategies based on your experience and what you've seen?
Well, I'm not directly responsible for the regulatory end, so or the policies. Mine was more of evaluating where is the water coming from, how much is there, and what is the water quality. But from my knowledge, the regulatory end, that's something currently we're looking at and working with the Texas Road Commission, the TCQ, to assess how we're going to use this water for beneficial use once it's cleaned up. And of course, we're looking at everything from reuse in the oil field. Now, this is beneficial water. Water's being cleaned up, not to be confused with produced water that's immediately returned back to the field for use for fracturing. And by the way, just FYI, we did a survey last year, and roughly 60% of the water used in hydraulic fracturing in the Permian, this is Permian wide, not basin specific, is from produced water. As far as the regulatory end of discharging water, it all has to meet a standard by the TCQ and EPA that's pretty much drinking water. So the $64 question is, well, can we distinguish between different qualities for water that's used for, say, non-food crops and food crops, or livestock, all the way to obviously potable water. We're looking at discharge into the Pecos River, which obviously everything that the Pecos feeds into right now is way low. I think you're looking at like Lake Falcon at the end is like 16% full. Red Bluff, which is right there on the north end of Texas, right before it crosses into New Mexico, is 38% full. So, and then they're not going to discharge any water from Red Bluff this year. So there's a tremendous amount of water that we need just in discharge into these, like the Pecos River, for agricultural purposes.
Great, thank you. It looks like we just got quite a few more questions that came in from some of the attendees. Ahmed, do you want me to start from the top, or should I just kind of bounce around here? Some of the questions might be, I could see a couple look a little redundant.
Many questions on your cell phone, also on your.
Yeah, that's what I'm looking at. I'm just looking at the questions that came in through my cell phone. If you wanted me to go run through each one individually, start from the top.
Can pick whatever you want.
Okay. All right, Marshall, and Jeffrey as well, could use your responses to the following. So what does the future of water management look like in the Permian Basin, and what innovations specifically could shape it?
Well, I'll take a stab at it. I mean, of course, there's basically two methods to cleaning up water. And I'm assuming we're talking about not for fracturing, we're talking about specifically water for beneficial use. And what are the strategies for relieving the burden on these saltwater disposal wells? And I apologize for being late. I'm triple booked today. Is that what we're looking at specifically here?
I would say, I think it's probably both. We're already on the subject of ESG, so why don't you tackle the reuse end of it, and then maybe Jeffrey can talk a little bit about, you know, the impact, you know, and shaping the impact of water management on the shale side.
Okay. Well, I mean, again, the reuse, if we're talking about just using produced water for hydraulic fracturing, we're already at 60%, and the group that is looking at, along with us, as far as quantifying the water and whatnot, I'll both estimate that we'll easily get to 80+% of the water is going to be recycled back to the operators for use in hydraulic fracturing. The only barrier to that is some legal issues along who owns the water. That's pretty much been handled by the Texas legislature. There's still obviously money to be made, so attorneys will chase it as to some maybe possible loopholes in that. But by and large, you know, the operator owns the water, the produced water, because it is considered a waste. As far as that goes, even if you were to use all of the hydraulic fracturing water for hydraulic fracturing, there still is a substantial amount left to be disposed of. That the process of taking the water to beneficial use is about a 50% efficiency process. That is, you go in with 100 barrels of produced water, you get 50 barrels of beneficial use water. The remaining higher salinity of water that is the other output of these systems, that water is injected. So basically, you've reduced your water injection by half. The issues around that water, obviously, you've relieved 50% of the injection, and hopefully the seismicity issues and things of that nature would be relieved. The other parameters you're looking at is the cost of doing all that. Right now, it's over $2. We're still analyzing several different techniques. The techniques fall into two branches, and I apologize if Jeffrey's already covered this. One is membrane technology, and the other is thermal. Membrane's only good up to a certain salinity. Then you have to go to thermal, and which is quite costly. There's certainly things like combining this with your small molten nuclear reactors that they're working at Abilene Christian, and other uses of obviously your natural gas being produced, to possibly get those costs down. So the trick for all of this is how can we reduce the cost, make it less painful to operators, and then what policies can we come forth with that's, you know, friendly to both sides, both the operator and obviously the end use people.
Great, thank you. Jeffrey, not sure if you have anything to add there, but the floor is yours if you do.
Yeah, Marshall, I thought that was a great answer. I think we're going to have to continue to go at it from every angle we can. Kind of agreeing with what you're describing there. We're going to have to continue to inject produced water. We're going to have to continue to treat produced water, reuse it for frac, and try to increase the usage rate as much as we can, above 60%. Some of our operators are only fracking with treated produced water, and that's excellent. And then as well, we're looking at out of basin disposal to also continue to meet the demand and take away capacity that our customers need.
Yeah, and that reminds me of something. One of the things I came up with or looking at was trying to ascertain, of course, in Texas, we don't have to report to the road commission our amount of water we produce. We only can infer that from well test, which in Aris, which we've used all our data, has done. And we tried to check the accuracy of looking at that volume versus saltwater disposal, and then factor in, okay, if you assume that X% of the water, in this case, 60% right now is used for hydraulic fracturing, can you do the math? Does it work out? And the answer is it does, actually. The well test actually results in pretty accurate volumes. But the interesting part about this whole study is we looked at both the Delaware and Midland separately, those two basins. And the Delaware where the Midland Basin, where the saltwater disposal was much less than water produced now. The opposite is true in the Delaware, and the reason for that is because of all the water that's being shipped from the New Mexico side of the Delaware into Texas.
Great, thank you. Next question from one of the attendees is, should operators shift away from deep well injection? And if so, what are the alternatives?
Yeah, if you want to take a stab at that first.
Deep wells are a challenge. They're very expensive to work over. They're very expensive to drill, and they're risky. And so we have some Devonian wells in New Mexico that they're very successful. And then we've had some workovers that have been extremely challenging. So it's another one of those risk versus rewards that you have to look at in the upstream and midstream environment. And we're going to have to continue to do that. We're permitting new Devonians across the Delaware, and we're doing that where we need to align with commercial agreements we have with producers. Now, I think our preference would be to build pipelines, to build ponds and recycle facilities, and not invest capital in the Devonians. But that's not to say that we won't do that in the future. That's a decision above my pay grade. We'll also look at out of basin disposal, where we could look to take advantage of beneficial reuse technologies that Dr. Watson was just describing, and then as well permit and inject in shallow disposal wells outside of the basin. And I mean, back to, not to beat a dead horse on power, but Devonians consume a lot of power. It takes higher horsepower units to inject that far down hole at higher pressures, and you're building injection flow lines out of ANSI 2500 flanges versus much lower pressure rating piping as well. So it's they're big wells, but there's big challenges with them as well.
Great, thanks, Jeffrey. So we talked a little bit earlier about seismicity, and Jeffrey, you did a great job of talking a little bit about Aris and how y'all kind of manage or mitigate seismicity. These two questions, it's a two-part question, dives a little bit deeper. And the first one is, how significant is the link between saltwater injection and induced seismicity in the Permian Basin specifically? And what mitigation strategies are most effective in reducing seismic activity related to water disposal?
I couldn't speak to the correlation of them. I would honestly defer to other folks and maybe somebody with a more of a downhole subsurface background than myself. I got a mechanical engineering degree right across the hall from you, Dr. Watson, at Texas Tech. And I think how we look at it is we evaluate activity every week, and we have grown much more our SWD capacity with shallow wells versus deep wells. And we're going to continue to do that. And we're going to continue to take the lead with beneficial reuse projects and evaluating out of basin disposal.
Yeah, the only thing I can add is the BEG actually came out with a study recently showing the interaction of these faults with injection wells. And to try to summarize it, sort of, is these deeper injection wells, like in the Devonian, are when they're nearby faults and the water can find its way through the reservoir, and usually the Devonian wells are naturally fractured, not to be confused with faults, find their way to a fault that I know 10 to 18,000 foot seems deep, but I mean they're finding faults at that level, and those faults communicate with true basement faults that are 5 to 7 miles below the surface. And that's where they're seeing the corollary between injection wells, and those injection wells the water finding its way to a shallow fault, again, shallow being 10 to 18,000 feet. And then those faults communicate with deeper faults. And that's kind of a synopsis of kind of what that study showed. It showed which faults, and there were definitely clusters of faults in a trend in the Delaware that where they could trace back the seismic activity to. And so I think the simplest solution was basically moving away from a seismically active area or wells that were inducing seismic, and potentially moving your injection to another spot, or reducing the injection rate into those wells.
Makes sense. Seems pretty logical. One more question on seismicity. Are current water disposal and injection regulations sufficient to mitigate seismicity risks?
My personal opinion is yes. I think the Rail Commission is very interactive in what's going on and responsive to seismicity issues in the manner I just spoke of. So I think that always personally, less regulation is best. You can over-regulate any industry, and I certainly want to avoid that. But I certainly, as engineers, our first code of ethics is protect the health, safety, and welfare of the general public. So we've got to keep doing that.
Great, it's a great answer. Thanks, Dr. Marshall. Jeffrey, this next question I'm going to steer towards you, because I think you could probably offer the attendees a firsthand answer to it. What are the technical and economic barriers to scaling up produced water recycling?
I would go back to some of the key points that I made at the beginning of the meeting. Is it takes a long time for us to deploy a permanent facility when it's in a greenfield environment. If we're not expanding an existing facility, then we have to work around the timelines, whether for inlet pipeline right of way and for pipeline right of way to deliver to the frac site. If we're looking to build a new 1 million barrel pond, that's a 20-acre site. the permit process there, it seems to be relatively easy if you're outside of a karst area in the state of New Mexico to get an approved C-147 package for a pond. But then you have to turn around and work with the BLM or the state or the fee owner to get the surface easement to go out there and build the pond. And then once you're approved to build the pond, you've got another 3 months to build it. And if you don't have any weather delay, then you have to stand up the recycle facilities adjacent to that facility. And it's these facilities, as you guys know, working in the oil and gas environment, once you plug it in, it's not like turning a light switch on and you go from 0 to 150,000 barrel a day treatment rate. There's people involved, there's processes involved, and you've got to align all these things together, transfer in this amount of volume on a 24/7 operation, treat it, and then deliver it to the frac site to keep the customer happy. And so all of that makes it challenging. That's also what makes it fun. And you got to run a lot of parallel paths on projects and get them shovel ready. And when the opportunity presents itself, that's when you go out there and execute.
All right. Next couple of questions around produced water management and recycling. Specifically, what percentage of produced water is currently being recycled in the Permian, and how can this be increased? And how do operators decide between disposal and treatment for reuse?
I think Dr. Watson was speaking towards 60% treatment rate earlier. That's probably a good baseline assessment, or certainly is a good baseline assessment across the basin. And then certain operators target 80, 90% where they can. And if you have the amount of volume and you've been able to aggregate that much produced water in the area of the frac, it is the most economic thing to do. And that's the business that we're trying to bring to the table. And then that's what the operators utilize as well. But it's not always the case. Sometimes you do have to rely on brackish water to make up the treatment rate, especially if you're pumping at those 150 to 250,000 barrel a day rate, depending on the size of the frac fleet. That often determines what the operator has to do.
Yeah, basically, I agree. I don't have anything to add to that.
All right. Last part to this section is, what advancements in water treatment technologies have been most effective in the Permian specifically?
Could you repeat that, please?
Yes, sir. What advancements in water treatment technologies have been most effective in the Permian?
I think the verdict is still out on that. I don't have an answer to that. I mean, we're like I said, we're just now looking at several pilots that are being run now and evaluating the water from those pilots. So I don't have an answer to that just yet.
Okay, Jeffrey, any thoughts on that one?
I agree with that with respect to beneficial reuse. With respect to treated produced water for frac, we've had the best success with DAF units, and a certain vendor over another, but I'll kind of leave that to myself.
Great, thank you. Couple of general questions that popped in from the attendees. What are the biggest challenges facing water management in the Permian Basin today? Talked a little bit about regulation. We talked a little bit about, your infrastructure, efficiency, how to drive efficiency. Any other challenges come to mind?
I mean, I think we've already kind of danced around it. It's the cost, number one, of getting water to beneficial use. And then secondary to that, what we're studying, what type of water quality are we being mandated to go for here? Can can that change? Can we have different water quality requirements for different uses? Because like I said before, right now there's just one, it's potable water and that's it, before you can discharge. So, you know, there's cost, and then secondly, there's policy. To me, those are the two big items.
Okay, and then in terms of, you know, and I think we probably touched on this one as well. So apologies to the panelists if some of these seem redundant. I just want to make sure we cover all the attendees' questions. But the next one is, what are the key environmental concerns related to produced water handling in the region?
From an environmental perspective, for us, it's spills. I mean, we run a really stringent program, and one of the things that I'll mention that worked well for us, and we deployed it last year, is there's a portal that we use. It's called KPA. There's an app on my phone, and we rolled it out to all of our operators in the field, and it gives them the ability to report spills at the tip of their fingertips. We can log latitude and longitude, note the time of the event and where the location was. And then that, just being very diligent and reporting everything, allows you to run an efficient business. And all of those are indicators that gives you the evidence that you need to make changes in your operation to eliminate them. And we've certainly done that. We've got great spill metrics that we're tracking this year and last year, and I think that was a big part of it. By pushing out those tools and utilizing technology, all of our operators have an iPhone. They can download that app. Everybody has access to the portal, and then as soon as they enter it, everybody on the safety and environmental team get that report, and we can respond accordingly. And we lean on third-party environmental service companies to go out there and quantify the risk and quantify the size of the spill. And then we clean it up and follow whatever government or whatever the ruling party is, whether it's NMOCD, Railroad Commission, or State Land Office. And I mean, that's something that we've certainly done. But I mean, that's not unique to produced water side. I dealt with that on the upstream side of the business as well. And it's what you have to do. But that's a technology there that I think is taking the reporting and response to the next level for us.
Great, thanks, Jeffrey. Next question is, what are the most sustainable water sources for hydraulic fracturing in the Permian Basin?
Treated produced water.
Agreed.
Which is a good segue into the next question. How can operators reduce their reliance on fresh water in drilling and completion operations?
I think everybody's working to do so. You know, from a selfish point of view, working at Aris, if operators can give us the longer lead time we have to plan and be ready to deploy treated produced water to feed the frac site, that's going to increase the probability of success. So we need to work together to make that happen, and we can do it.
Great answer, Jeffrey. Thank you. What role do brackish, or does brackish water and alternative water sources play in in Permian operations?
Well, I mean,
yeah,
it
go
could
ahead.
be compatible. No, go ahead, Jeffrey, please.
I think brackish water is continuing to be a smaller part of the business. You know, if you have to react, and then if the operator changes their schedule and there is a brackish water supply source, that is going to make up a percentage of the frac, whether it's 10, 20, 30%. That may be what it is, but we're going to continue to try to leverage and redeploy as much treated produced water as we can. But brackish water is still out there, and the people selling brackish water, they're in the business to sell brackish water, so that's what they're going to try to do.
Yeah, and it obviously more expensive. I mean, but the
Yeah.
treated produced water is definitely the way to go. And there's more than enough of treated produced water to handle our fracturing needs as far as our study goes. But as the state of Texas, we're looking at an 18 million acre feet per year shortfall in water through 2070. That's a big number considering, you know, I'm sorry, I said, it's 18 million acre feet is the demand. The shortfall will be 7 million. I'm sorry, 7 million acre feet per annum through 2070. And that obviously 7 out of 18 is a big fraction. So it's a big number. And one of the other areas we need to look at, or the state of Texas looking at, is brackish water and desalination plants for that brackish water. I mean, that's going to be one of our biggest answers to our water nexus that is the biggest thing facing Texas, because that's the roadblock, because Texas right now economically is booming more than any other state. And the roadblocks to stop that is water. And I have to run to my next meeting. I'm sorry, but I've enjoyed it and thank you for having me.
It's been a pleasure. Thanks for jumping in, albeit even for a short window, and enjoy the rest of your day, Dr. Watson. Thank you. All right, so we have roughly about 15 minutes left-ish. I think we've covered pretty much all of the questions. There's a couple of questions remaining here that I think are a little bit redundant. So I don't know if there are any other questions that have come in, Ahmed, through the chat that maybe I haven't seen yet.
Check your email. More questions in your email.
I'm sorry, I can't hear you.
I sent you some questions to your email address, so check your emails.
Oh, email now. Okay.
Yeah.
Hang in there with me, Jeffrey.
All good. I'm good.
Okay, so we're going to dip a little bit back into regulatory and policy consideration. Should there be a regional or federal framework for water management in the Permian, or are state level policies sufficient?
I would say state level is sufficient. Yeah, I mean, I'd be concerned that a federal ruling would be just extend the process, and then you'd still have to turn around and deal with the states.
Yep. How can operators navigate the difference in water regulations between Texas and New Mexico?
And that's a challenge. I mean, we have to stay ahead of that every week. And sometimes in the state of New Mexico, the rules change frequently. So you just have to have like any challenge in upstream, midstream oil and gas. You have to have a good network. And when you come up against challenges, you need to run as many routes as you can to understand what the problem is and what the options are.
Does Aris have a dedicated team? This is my question. Do you have a dedicated team to compliance, given the fact that, you're dealing with rules in different states that change quite often?
That rolls up in our land and regulatory team, and we have in-house capabilities, and for specific permit applications, whether it be ponds or wells, we may leverage a third party to work with to figure out all of the boxes that we need to check and do it properly to get the projects ready to execute. And that's something that we do. We have recurring meetings every week on that. So that's being on the capital side. I'm involved in the planning and regulatory side. as well as once we get that project ready to release for construction, I, I, I see them being built and executed in the field. So it takes over a year to plan and design some of these projects to meet the timelines that we need. And that's what we have to work through.
Great. Next question is, are there lessons from other oil producing regions that the Permian can adopt for better water governance? It's a great question.
Yeah, I'm gonna get the example wrong, but I know in the Rockies there are operators and there are other midstream companies that treat produced water and discharge of it into rivers. And that's what Dr. Watson was speaking about earlier, the desalination projects to dispose of into the Pecos River Reservoir. That's something that we're trying to bring and make commercial in New Mexico and in Texas. That's certainly one of them.
Great. Then we have a few more questions around water treatment and disposal. First one is, what are the limitations of current water treatment technologies and what breakthroughs are needed?
Okay, two things come to mind. Limitation in my mind, and sorry for repeating myself, but is power supply from the utilities, and that impacts everybody from the upstream to the midstream environment. And it's, in my mind, it's a really big deal. And I think the hate to rain on their parade, but I think they're behind the 8 ball. And I think we need to build and construct more natural gas power plants in the state of New Mexico and in the state of Texas. And we need to get after that. And that's what's going to really decrease fixed costs and decrease emissions across the industry. And from a federal perspective, because you brought that up, maybe that's something that they can help out with to get across the finish line. That's the main thing that comes to my mind. And then the other thing is tying back into what Dr. Watson was explaining is the cost of treated produced water for a beneficial reuse perspective, getting that treatment cost down and making it economic to compete against these other uses of treated produced water. And getting that treatment value below $1 or below from where it is today at $2.
Okay, next question is, how can water sharing agreements between operators improve efficiency and reduce disposal volumes?
I think that's a good idea. I think operators would have to then align their completions and frac schedules with each other so that when somebody's flowing back, somebody else is fracking. And that's easier said than done with whether you're private or public. People are going to want to execute their capital plan the way they see fit to deliver their production volumes and their financial metrics independently. So that is a challenge.
Good idea nonetheless.
Yeah.
Okay, what are the potential risks of water treatment byproducts and how should they be managed?
This is an indirect answer, but I mean, it's the same risks that I had to deal with when I was on the upstream side, and that's pressure and H2S and temperature. We deal with that every day at the reuse sites. We have H2S monitors. There's new technologies out there that folks are other operators are deploying, but there's 4-gas monitors. It used to be these huge devices. Now 4-gas monitors are very similar to the H2S kind of yellow Honeywell device that everybody can wear on their shirt. But some of these new devices have GPS locate functionality. If the operator does get into an issue, they can hit a button to signal SOS to the control room. And that's not unique to treated produced water operations, but it's certainly something that we all deal with on the upstream oil and gas front. And that's, I think, pressure, temperature, and H2S. So we're not unique to that.
Great. Okay, and I think we have one last question for you, Jeffrey, and then you're off the hook. Around future outlook. Could produced water from the Permian be treated for agricultural and municipal use in the future? I think you talked a little bit about beneficial reuse, and some exciting ideas and projects that y'all are working on. Maybe expand a little bit more on that for this question.
Yeah, I think there's absolutely opportunities for that, especially for crops like cotton, or other crops that you're not going to digest. That would be the first step. And I think that's pretty exciting. I think it'd be really cool to be a part of a team that brings that to the table. And if we can get on the same page with the state of New Mexico or the state of Texas, I think we can make it happen.
That's great. I actually agree with you 100%. I think that's really exciting. And first and foremost, I want to thank you for your time today. I think I've certainly learned quite a bit about water management, way more than I knew coming into this panel. We appreciate your time. I think to summarize, if I had to list the key takeaways of today, is some of the biggest challenges that are impacting water management. It would be regulation and cost, and you talked a lot about that. Efficiency and utilization are obviously the name of the game. Aris's infrastructure, I think, gives y'all a competitive advantage. And some of the exciting, new projects or pilot projects around beneficial reuse, I think are what are in store for the future of wastewater disposal and management. If I missed anything that you want to highlight, feel free to add. But unless there's any other questions from the attendees, I think we can certainly wrap this up maybe a couple minutes early.
Awesome. I think that's a great summary, Miguel. I enjoyed this time, and Ahmed, thanks for sending me everything to get set up, and I
Thank
enjoyed
you.
it.
Thanks for carrying the bulk of the workload today, Jeffrey. You did a fantastic job, and look forward to meeting you in person someday. And
All right.
best of luck and best wishes to you and your business. You guys are in a really great business, an important business that's critical to the industry, and I'm excited to see what the future holds for Aris and for your side of the business and as it relates to the industry in general. So thanks again. It was a pleasure.
Thank you. Have a good day.
Thanks, Ahmed.